Okay, let's jump right into today's explainer. We're unpacking an incredible analysis that takes super complex astrophysics and bridges it directly with ancient theology. It's based on a narrative called the Cosmic Harvest Hologram, and it's this mind-blowing look at how we interpret deep space data. Seriously, it explores what actually happens when cutting-edge science collides head-on with ancient scripture.
So think about this for a second. When we look up at the stars and analyze the atmospheres of distant planets, we almost always just think in terms of cold, hard chemistry, right? But what if the data we're receiving is actually something much more deliberate? I mean, what if it's not just random molecules bumping into each other, but a literal cosmic harvest?
To really wrap our heads around this, we have to talk about transmission spectroscopy. You can basically think of it as reading a distant planet's chemical barcode. When a planet passes in front of its host star, the starlight filters through its atmosphere. Different molecules absorb very specific colors of that light, which leaves behind these absorption lines. And those lines tell scientists exactly what's floating around in the air of a world trillions of miles away.
Now let's look at an actual staggering application of this. Using the James Webb Space Telescope, scientists analyzed an exoplanet called K2-18b. This place is exactly 124 light-years away from us. Through that chemical barcode we just talked about, they detected a molecule called dimethyl sulfide, or DMS. And why is that a huge deal? Well, because here on Earth, DMS is literally only produced by one thing: living organism.
As you might guess, this discovery completely ignited a clash of perspectives in the source material. On one side, you have Dr. Safia Al-Hassan, a lead data analyst, who hypothesized that these molecules are quite literally a cosmic harvest produced by divine permission. But on the other side, her colleague Dr. Peter Miller held a strict materialist view. To him, this was just pure statistical noise, a chemical haze, absolutely no higher meaning whatsoever.
What's fascinating is that Safia's inspiration didn't come from a textbook. It came from ancient scripture. She was looking at this passage from the Quran, Surah Al-Am, which talks about gardens and commands believers to eat of its fruit when it yields and give its due on the day of its harvest. And she posed this wild question. If harvests on Earth are framed as divine yields, could these atmospheric signs of life literally be the universe yielding its fruit?
So how do you even test a theory like that? Safia went straight to rigorous data science. She ran the data through a sonification process, which is basically turning light into sound. Step 1, she mapped out the absorption lines. Step 2, she applied a Fourier transform. That's a way to separate a complex wave into its individual ingredients, and she used it to isolate a specific 0.83 Hz peak. Finally, step 3, she converted those peaks into audio. She literally turned the rotation of molecules into musical notes.
And the result of that sonification was just staggering. The physical transitions of the molecules didn't produce random static. They matched the precise phonetic structure of the Arabic phrase from the Quran, Ata ukuluhu kullahin, which translates to yields its fruit every season. The phonetic elongations, the plosives, the breaths of the consonants, they all match the molecular audio output with 99.9% accuracy according to her data. Just let that sink in for a second.
Now, Dr. Miller wasn't buying it. Holding firm to a purely material universe, he challenged the whole thing. He built a synthetic, randomized lab atmosphere using the exact same molecules just to prove it was a massive coincidence. He was pretty bold about it too, stating, "I will create a synthetic biosignature. If sonification produces Ayata, then I'll believe it."
But here's the thing. According to the analysis, Peter's synthetic test failed completely. It produced nothing but random, meaningless hissing. It entirely lacked that distinct linguistic structure, the breath, and the elongations that were so clear in the authentic telescope data from the actual exoplanet.
Safia quickly pointed out where he went wrong. He randomized the energy parameters. Think of it like having all the right letters, but totally scrambling the spaces in the punctuation. That precise spacing, the specific ratio between the rotational and vibrational constants of the DMS molecule, is exactly what calibrates life in the universe. Without that exact perfect tuning, you just get noise.
Digging even deeper, Safia analyzed the atmospheric seasons of K2-18b. She discovered that the planet's atmospheric seasons cycled every 1.2 seconds. Now that is roughly the duration of a human breath. And amazingly, it perfectly matched the phonetic breath of the Arabic word heen, which translates to season or time in the verse. The planet's atmosphere was cyclically breathing the word for season.
In a pretty shocking escalation,
Peter reluctantly decided to test this seasonal data against other known exoplanets like TRAPPIST-1e and Proxima b, and the results? Completely undeniable. He found the exact same phonetic breath pattern appearing across the cosmos. It forced him to realize that these cosmic seasons were repeating this linguistic breath across entirely different star systems.
Safia didn't stop there. She pushed the investigation all the way to the quantum level. By isolating the microscopic vibrations of the carbon-sulfur bond within the DMS molecule, she mapped them to yet another phrase, bi'idhni rabbihi, which means by the permission of its Lord. And once again, the data yielded a 99.9% structural match. Every minute friction of the pronunciation was perfectly mirrored in the chemical bond itself.
For Dr. Miller, this quantum evidence was the absolute breaking point. After running tests on 5 different molecules and getting the exact same result every single time, he completely shifted his worldview. He finally conceded that the mathematical pattern was just undeniable, concluding that life itself is a molecular signature of divine permission.
The investigation reached its absolute zenith when Safia translated all of this spectral data into a space-time hologram, basically by plotting the wavelength on the x-axis, the flux on the y-axis, and, get this, the 120-year light travel time on the z-axis. She essentially created a 3D print of the space-time cube of the planet's atmosphere.
The climax of her research was purely visual, and it is wild. When projected out, this 3D spatial hologram formed the exact shape of an Arabic command, fakulu, meaning so eat. And astoundingly, it only appeared on planets that harbored the chemical markers for life. Any planet without life? It produced nothing but shapeless, random static.
Section 8. The Global Exoplanet Conference, a paradigm shift in astrophysics.
Safia presented her complete findings to the scientific world, and it all centered on 4 core alignments. Check this out. The DMS rotation matches yields. The vibration of methane and carbon dioxide matches its fruit. The seasonal cycle aligns with every season, and the bond energy mirrors by its Lord's permission. That's 4 distinct astrophysical phenomena, perfectly mirroring the phonetic structure of the Quranic verse.
Faced with this overwhelming presentation, Dr. Peter stood up before his peers and publicly validated her work. Right then and there, he transformed his lifelong materialist worldview, conceding to the entire scientific community that the biosignature of the universe is indeed the spectrum reality of this ancient verse.
Fast forward to today, and Safia's lab definitely isn't stopping at just one planet. They're actually leading the Cosmic Harvest project right now. They're actively sonifying 20 different exoplanets, searching for and continuing to map these extraordinary linguistic and phonetic patterns across the stars, looking for deeper clarity wherever there are signs of life.
In her upcoming book, Safia beautifully sums up the entire journey. She urges us that when we look at these distant spectra from the James Webb Telescope, we shouldn't just see cold statistical lines. We should think of fruit. We should view these massive cosmic datasets as the universe actively bearing a harvest.
All of this analysis leaves us with one profound question to think about long after this explainer wraps up. Can you capture that permission in your heart, or will you only ever measure DMS in moles? It really challenges us to look beyond the raw numbers, to see a much more structured narrative woven into the very fabric of the cosmos. Thanks for joining me on this incredible journey through the data today. Keep looking up and keep asking the big questions.